Hi, fitting and turning level 3. Today we're going to cover the center lathe, and you already have covered it in level 2, but knowing students, by now you will have said, we don't know it. You were supposed to know it. So I'll just quickly recap on some of the N2 work. First thing, what do we use this machine for? It's used for a number of different machining operations, from parallel turning, from taper turning, drilling, boring, reaming, and we can manufacture a large quantity of different work. I know in this time of the lockdown and the government is in serious shortage of ventilators, even some of those ventilator components can be manufactured on a machine like this, and obviously including the milling machine. And obviously not the whole machine, but all the mechanical components. Coming back to the center lathe. You have to know the components, just as you would know the components in a car. You know where the wheels are, you know where the engine is, you will know where the gearbox is. Same with this machine, you need to know where the components is. I know you'll say, yeah, but we've learned it in level 2. I know, you've forgotten already. So let's just quickly run through the different components on the center lathe. Starting here on the left-hand side. We got our headstock. And what's the function of the headstock? The headstock contains the electric motor as well as the gearbox. With the gearbox, we can select different spindle speeds as well as different feeds. Also for driving the lead shaft when we're cutting thread. Coming to the front here, we have our spindle. This is not the spindle, this is a chuck. Behind the chuck is the spindle, and on the spindle we can fit different clamping devices. From a 3-jaw chuck, the one we got here, the 4-jaw chuck, the faceplate can be clamped on the spindle. Coming this side, we find our bed, we find our tailstock, we find our carriage. The top part of the carriage is known as the saddle. On top of the saddle, we have our cross slide, compound slide, tool post. On the front here, these two shafts will always be there. The bottom one is not on all the lathes. This is only for starting and stopping the machine. But this two shaft here, the one with the thread on, is known as your lead shaft. And the lead shaft is for cutting thread. The one below it is your feed shaft, and that is for the automatic feed. You got your splash plate here at the back. You got your base, and down here you got your automatic, your emergency brake will be situated here. Here's a switch for your cutting fluid, and there's all your components on your center lathe. Let's quickly revise the safety. There are 4 sets of safety involved when you're going to work on a machine. Not just a center lathe, but any machine, and that's your environmental safety. Environmental safety, we refer to the area around the machine, and that must be free of any obstruction. The floor must be non-slippery, no oil, water, or anything like that on the floor. Sufficient light, so we can see what we're doing. And remember, no fluorescent lights. Fluorescent lights will cause a stroboscopic effect on your rotating components, which can be dangerous. Make sure there's enough ventilation and fresh air, because we don't want to fall asleep while we're working on a machine. That is our environmental safety. Next, we look at ourselves. What type of protective equipment and clothing should I have? The first one is an overall or a dust coat. Very important is short sleeves. Short sleeves, you don't want to have any loose piece of clothing getting caught in a rotating machine. Safety boots, and then obviously safety glasses for your eye protection. Ear protection can be worn if the workshop is quite noisy. I prefer, when I work on machines, if the workshop is not too noisy, not to wear ear protection, for the simple reason I want to hear when something is going wrong with the machine. Wearing ear protection is very difficult to find if anything is running wrong on your machine. A dust mask, not always necessary, but when you work with certain materials such as cast iron, it can give off dust, which can be detrimental to your health if you inhale it. Right, coming to the machine itself. What safety is involved here? Now, there are two sets of safety here. One, before you're actually going to work on the machine, and one while you're actually working on the machine. Now, what are we going to look at before you're going to work on the machine? First, make sure that you are familiar with the machine. Just like one car varies from another car, the handbrake sits here and the other one, the handbrake sits there. This machine exactly the same. The stop start sit at different places. The emergency switches sit at a different place. The gearbox work differently. So you have to familiarize yourself with the machine itself. Make sure that all the guards are in place. If you're going to use cutting fluid, make sure that your cutting fluid is filled and it's working properly. You don't want to run around while your machine is working and then find out you haven't got cutting fluid. Make sure that your machine is nice and clean. Obviously, once you've worked, you're going to clean it, oil it. I've been working this morning, so you can see currently it's a bit dirty. But in the afternoon before I leave, I will clean my machine. So those are the safety before I'm going to work. Getting closer to the machine itself. I don't know who have worked on this machine before me. So the first thing I'm going to ensure is I'm going to make sure that my chuck is properly tightened on my spindle. This is a relatively small chuck. But if you work on a lathe where the chuck might be 300-400 kilograms and you are machining and it comes loose, it can be not so good for your health. Huh? So I'll make sure that my chuck is securely clamped. Right, now I'm basically ready to decide what am I going to do with this machine. What I'm going to show you today is the ISAT project that is to be done for level 3. Some of the work is done on the lathe and some of the work is done on a milling machine. We're obviously just going to concentrate on the lathe. You're going to get a drawing. Just get my drawing here. There's my drawing. It's a shaft that is 100 millimeters long. It will have a 3 millimeter groove, 55 millimeter from the one side, or if you work from the other side, 42 millimeter. And that groove will be 3 millimeter wide, and the diameter across is 23 millimeter. You'll put chamfers on. And that's a workpiece that has to be manufactured. We're going to go through all the steps that is required to perform that or manufacture that workpiece. First thing, make sure that you got all the necessary equipment that is required. You're going to need a knife tool, either a insert tip tungsten carbide, or you're going to need a high-speed steel tool. If you're going to require a high-speed steel tool, Obviously you have to sharpen it yourself with all the correct clearances. And in my case, I'm going to use a high-speed steel because we're working on mild steel and it's not all that hard. And at the same time, I like to practice my skills grinding a high-speed steel tool. I've already sharpened this tool. The only thing I haven't done, I haven't broken the sharp edge there. That edge is very sharp, so I'm just going to use a stone, just breaking that sharp edge. That will also just give me a little bit of a better finish. I'm also going to require a grooving tool. And this specific grooving tool is a tungsten carbide insert. I'm going to use this one. My measuring equipment that I'm going to require is a vernier caliper, a micrometer. In this case, I'm going to use a 25 to 50 millimeter micrometer because the shaft is bigger than 25. I'm also going to use a steel ruler. So that is my measuring equipment. I'm also going to require my material. This is my stock material. This is how it comes from the steel mill. Once again, you can see it got that black scale on the outside. And this stock material got a diameter of plus minus 30 millimeter. You can see I say plus minus, remember, as hot rolled or extruded steel. So it's not exactly uniform throughout. If you look at the original drawing for the ISET project, you'll see it say 30 millimeter. You cannot cut it 30 millimeter because it's already 30 millimeter. So I made an alteration to the drawing. I made it 28 millimeter for the project. You can cut it to that length, which is slightly longer than what it's supposed to be. It's supposed to be exactly 100. This is cut to 105. The problem with, if you work with stock material where you cut it nearly to length, is using a 3-jaw chuck. It means you'll only be able to cut up to a certain point. Because your vise is going to be there. You'll cut up to a certain point. You have to remove it out of the chuck, turn it around, and cut again. The problem there is, using a 3-jaw chuck, you'll lose your centricity and the workpiece will not run centric. You can utilize a 4-jaw chuck, but that is very time consuming. So the method I'm going to prefer is using stock material of any length. Obviously, it must not stick out too far out of the lathe at the back because that's dangerous in itself. But I'll use a longer piece of stock material. This will allow me to clamp it and do all my machining in one without having to remove my work. In other words, I won't lose my centricity. The only thing I'll have to do at the end is spot it off and then machine it to the correct length. And in that case, obviously I have to remove it out of the chuck. So right, there's as far as my stock material is concerned. Now whenever you're going to do any machining, the secret is planning. You must work out the steps that you are going to follow. If you don't follow the correct steps, then you're going to find yourself running into troubles where you should have done this, now you have to do it later, and then it doesn't work out. So I've already in my mind, I've played off the procedure and steps that I'm going to follow in manufacturing this component. So the first thing is, I'm going to face it. This has been cut off on a power saw, so you can see it's very rough. Been cut off on a power saw. And one of the things you do find with a power saw, it sometimes leaves a piece of material sticking out. I already took this to the pedestal grinder and I've just removed it. Important that you do it, because if that piece of material is rough like this and your cutting tool gets there, it very easy breaks your cutting tool. And then you have to go and resharpen it. So I just went to the pedestal grinder and I've just removed all the burrs and pieces of material sticking out so that I don't break my cutting tool. So my first process is going to be facing. Now what is facing? Facing means machining across the face of the workpiece. And that is to ensure that we get this surface exactly 100% flat. So that's my first process. So to face, I'm going to cut across. So I can either use a knife tool, and all I have to do is swing it at a slight angle. Or I can use this facing tool, which is also tungsten carbide. This is not replaceable, it's been soldered into place. So I can use this one. All right, here's my tool holder. Just going to make sure it's nice and clean. And I'm going to clamp my tool. Now here's very important. Where do I clamp? Do I clamp it there? The rule is you clamp it as deep as possible. You clamp it as deep as possible. If you clamp it there, you'll have a lever effect. And with a lever effect, it will cause the cutting tool to very easy under pressure become dislodged. And when it comes dislodged, it can cause some damage to your workpiece and it might even injure you. So clamp it as deep as possible. Obviously you can't clamp it all the way, but as deep as possible. Right. Make sure that my cutting tool is nice and tight. What I normally do is just tighten lightly and then I start again to make sure I got it tight. And this is a very important safety rule while you are machining. Make sure that your cutting tool is securely clamped. Right, now is one of the things that a lot of students forget. By using your tailstock and your center, you have to get the cutting tool to be exactly center height. So what does that mean? By using this up and down adjuster here, I have to adjust the cutting tool to be exactly center height. If it's not center height, if it's below, what will happen is the cutting tool, when you are machining, and your cutting tool is below center height, it will tend to dig in and break. If it's too high, the cutting tool will only rub and it will not cut. So make sure that your cutting tool is exactly center, and to get your center, you have to use your tailstock and your center. Just be careful when you do fit your center. Turn your spindle a little bit forward, and then you slide it in, and make sure it slides in all the way. I find students, they tell me, yes sir, but it is center height, and I find it is hanging like that into tailstock instead of being fully into the tailstock. So make sure it fits all the way properly. Swing around, and now you will see that it's at least about 2 millimeters below center height. Make sure everything is clamped, and you'll see that when I use the levers to tighten and loosen, I often use this part of my hand. I don't just pull it, I hit it. So if I want to loosen this, all I do is I'm going to give it a tap with my hand, and it will come loose instead of trying to force it. So even when I'm going to tighten it, I'm going to hit it with my hand. That will ensure it's nice and tight. And what I do find, quite often when you pull things, you tend to slip. And remember, everything here is there to injure you. The sharp edges, sharp cutting tool, if your body is going to come into contact with that, it's going to cut you. Right, so I've selected my tool that I'm going to use. I've decided on my first machining process, which is facing. So I'm going to face. Take my workpiece, and I clamp it in as deep as possible in my chuck. Let it stick out, say, 20 millimeter, that's good enough, and make sure that your workpiece is securely clamped. I find quite often when girls work on it, they say, but sir, I'm not strong enough to tighten or to loosen. Your strength is in your shoulders, not in your arms. So when you want to tighten, make sure that you get your body position behind the chuck. You can't tighten it in that position because your body can't get behind it. So make sure your body is in line. So you move your body around. Get in line, and all you do is keep your arms straight, and you use your shoulders. That's it. And the same when you want to loosen. You hold it, and you can even use your hand in loosening it that way. So it's not, but say I'm too weak. There's no excuse. You're strong in your shoulders. So make sure that your workpiece is securely clamped. And now I want to come to a very, very important safety regulation. And it's that. If I find a student operating in a workshop and he leaves that chuck key in that position, that is his lesson over. That is extremely, extremely dangerous. Your chuck key must never ever be left in the chuck. So it must be like a magnet. When your hand goes, it goes with your hand. It never stays there, never ever. You remove it, and there's a very simple explanation for it. When you're going to start this machine, and that chuck key is in there, what's going to happen? It's going to come flying out. Hopefully it's going to hit you and not somebody else, but the chances are pretty good that it's going to hit somebody. And it's coming out there with a very high speed. And it's a heavy piece of metal, and it can severely injure you. So always make sure that you remove your chuck key once you have tightened or loosened. Right, so there's my workpiece clamped, and my first machining operation is facing. And all facing is to make it straight and give it a good finish. Swing my tool over to a slight angle. And I'm going to use automatic feed. Now you can see my cutting tool is still some distance away from my workpiece, and that's for a simple reason. Before I start using the automatic feed, I want to make sure that I got my directions correct. So quickly start, engage, and I can see that my cross slide is moving, and that's the one that I'm going to require. If it was in that position, I find that my longitudinal feed is moving, and that's not the one I want. So I will ensure that my feed direction is correct before I'm even close to my workpiece. I don't test it there, I test it away. I also will ensure that I got my correct speed for the material. Right, in our next lesson, we are going to do the facing operation. What have we done today? We did a bit of revision of level 2 work. We looked at the different safety aspects around the center lathe. We had a look at all the different parts on the lathe. We had a look at selecting the correct cutting tool for the specific operation, how to set up the cutting tool to center height. We looked at our first machining operation that we're going to perform, which is facing. So that's what we've done in this lesson. If there's any questions, feel free to refer to the bottom of the screen. Contact us. We'll assist you as much as we can.